This problem is for you folks to try on your own. F of x is e to the secant of x, and I'm asking you to find f prime of x. Okay, when we come back and work through it together, I will work through it twice, once using that u substitution method and once not. So work it out however you prefer, and then tune back in and we'll work through it together. All right, welcome back. As I said, I want to work through this one twice. Let's work through it first without going to the u's. Notice secant of x is in the exponent position. That's my input to the exponential function, okay? I may want to put that in parentheses just to give myself a visual cue. That's the inside part, okay? If I were evaluating this, I would start with x, then I would plug in secant of x, and then I would take e to that power. So I'm going to be working backwards as I take the derivative. So the derivative of e to the something is e to the something. So that's just going to be e to the secant of x. Chain rule times the derivative of the inside part. All right, so that's e to the secant of x. The derivative of secant is secant times tangent. That's secant x tan x. Very important here, by the way, that both of those functions get an x. That's how I know that that's the product, secant of x times tangent of x. If I didn't have an x here, it would be secant of tangent of x, which is a very different function. All right, if I did this one using the u substitution, I would say u is the inside part, that's secant of x. Go ahead and write that means u prime is secant x times tan x. Okay, and so then basically we're taking the derivative with respect to x of e to the u. First step, I take the derivative as if u is my variable. Then I multiply by the derivative of the inside part, which is just u prime. And then I have to rewrite everything back in terms of x. So e to the u is e to the secant of x times u prime is secant x tan x. Good stuff.